Okay, welcome back to another video on the Maths channel. It's your teacher Muslim here, and in this video we're going to be looking at solving problems with APs and GPs. So let's have a look at question A. Find the value of x if 3, x, 12 form an AP. Now remember, AP, an arithmetic progression or sequence, means that there's a common difference between the terms. So there's going to be a common difference between 3 and x, and from x to 12. So all I'm going to do is I'm going to create simultaneous equations. When I take a term and I minus the previous term, I'm going to get the same thing when I get a different term and minus its previous term. 12 minus x. Here I'm just going to solve this equation. I'm going to add x to both sides to give me 2x. I'm going to add 3 to both sides to get 15. That means x is equal to 15 over 2, or 7.5. And so we can see here we've got 3, 7.5, 12. They should have a common difference. So we would do 7.5 minus 3, that's 4.5, and 12 minus 7.5 has a common difference of 4.5. Alright, let's have a look at question B. Find the value of x if 3, x, 12 form a GP. So because it's a geometric progression, or a geometric sequence, we know that they have a common ratio. So if we were to take a term and divide it by the previous term, it's going to equal the same thing as another term divided by the previous term. Well, here we're just going to cross multiply. That's going to get rid of our fractions. X squared is equal to 36. So x is equal to plus minus 6. So there are actually two answers here. We can see if we've got 3, 6, 12. Let's see what the common ratio is. 6 divided by 3, that's 2. 12 divided by 6, that's 2. They have a common ratio of 2. Or 3, negative 6, 12. The ratio here would be minus 6 on 3, which is negative 2. Or 12 on minus 6, which is also negative 2. So in this case, they would also have a common ratio, but this time of negative 2. So there are two answers for this. X can be 6 or negative 6. Alright, question C. The third term of an AP is 16, and the 12th term is 79. Find the 41st term. So remember, AP. So I'm just going to write down the nth term formula is equal to A plus n minus 1d. Okay, that's the formula for the nth term of an AP. Now this is saying that the third term is 16. So we got A plus n minus 1 is 2d. And that is equal to 16. We also know that the 12th term is 79. So if we were to write this out, the 12th term, A plus n minus 1, which is 11d, and we know that's equal to 79. How do we get this 11? Well, n is 12, so 12 minus 1 is 11. How do we get this 2? Well, n is 3, 3 minus 1 is 2. Now we can just solve this using elimination. I'm just going to take the bottom one and minus the top equation, because that's easier for me. So when we subtract a minus a is 0, 11d minus 2d is 9d, and 79 minus 16, that's 63. So we can see here that there's a common difference of 7. Well, what do we need to do now? We actually need to work out what the first term is before we can actually answer the question. Find the 41st term. So I'm going to sub that into this one because that looks easier. A plus 2 lots of 7 is equal to 16. A plus 14 is 16. So A is equal to 2. Now that I've done that, I know I can work out the 41st term. The 41st term is A plus n minus 1 d. A plus n minus 1, 41 minus 1 is 40, times d. So we have 2 plus 40 times 7, which is 282. Alright, question D. Find the first term A and the common ratio R of a GP in which the fourth term is 6 and the seventh term is 162. So I'm just going to write the nth term for a GP. I know that's A R to the n minus 1. So we know that the seventh term, I'm going to start with the seventh term, is A R to the power of 6. And we know that's equal to 162. Whilst the fourth term, which is A R to the power of 3, remember n is 4, so n minus 1 is 3. Here n is 7, so n minus 1 is 6. We know that the fourth term is 6. Now, in order for us to solve this, we are going to use elimination, but not through addition or subtraction, but through division. So I'm going to take the first line, I'm going to divide it by the second line. A divided by A, that cancels each other out. R to the power 6 divided by R cubed gives me R cubed. And 162 divided by 6 gives us 27. So that means that the common ratio has to be the cube root of 27, which is 3. Now, it's not plus minus 3 because you can see here that that is odd. If it was even, then there would be 2 possible answers. But whenever it's odd, there's only one answer. So we've worked out that the common ratio is 3. However, we still need to work out that what the first term is. So I'm going to sub this into any one of these. I'll probably sub it into this one. Here. A times 3 cubed is equal to 6. And that way I can work out what A is equal to. 3 cubed, that's 27. So 27A is equal to 6. So A is equal to 6 over 27, which simplifies to 2 over 9. And that's it. Alright, question E. Find the formula for the nth term of the sequence 2, 6, 18, etc. Now, this doesn't actually tell us whether it's an AP or a GP or not, so we actually need to work it out. Well, it looks like it's not an AP because I need to add 4 to get that. And when I add 4 to get to 6, I'll get 10, not 18. So I'm thinking it's a GP, but let's just double check. So the ratio would be 6 over 2, which is 3, and 18 over 6, which is also 3, yeah. So because they both give me the same ratio, I know that they have a common ratio, and therefore it's a GP. So the nth term will be A times R, which we've worked out here is 3 to the power of n minus 1. That's it. Now, if you want to, you can just write it as 2 lots of 3 to the power of n minus 1. But just remember that the power of n minus 1 applies to the 3 only and not the 2 as well. Do not do this. Okay, that is incorrect. Okay, use trial and error to find the first term greater than 1 million. Alright, so I'll just say, let's try 10. The 10th term is 2 times 3 to the power 9. That's 39,366. That's still too small. What about 11? Okay, so the 11th term, sorry, no, this is the 12th term, will be 2 times 3 to the power of 11. That's 354294. Alright, let's try this one. This one is, yes, this is the 13th term. The 13th term is 2 times 3 to the power of 12. Remember, n minus 1. That gives us 1062882. So we can see here that the first term that's greater than 1 million is this, because the 12th term is not over a million yet, but the 13th term is. Alright, well, what if we didn't want to use guess and check or trial and error? Let's use logs. So use logs to find the first term greater than 1 million. Now the easiest way to do this is to actually create an equation rather than an inequality. So I'm going to write the nth term. We know that's a times r to the n minus 1. But instead of saying that it's greater than 1 million, it's easy to write that it's equal to 1 million, and then we can use our logic and common sense to determine what the first term greater than 1 million would be. So now that we've done that, we've got 3 to the n minus 1. I'm going to divide both sides by 2. That gives me 500,000. And now I'm going to take my logs. So n minus 1 is equal to log base 3 of 500,000. And I'm going to use the change of base law here. So n minus 1 is equal to ln of 500,000 divided by ln of 3. So I'm just going to write here n therefore has to equal to that plus 1. So let's put that in our calculators. 500,000 over ln of 3 plus 1. So we can see here we get 12.94. So if it was possible for n to be a decimal, then the 12.94th term would be 1 million. But it has to be a positive integer. It has to be a whole number. So therefore, n has to be greater than 12.94. And therefore, n has to equal to 13. So that means we're looking for the 13th term. Okay. The 13th term is greater than 1 million. What will be the first term that's actually greater than 1 million? Well, what is that term? Now that we've done that, we can just sub that in. T13. 2 times 3 to the power of 12. Which is the 1062,882. 1,062,882. Okay, so that's it for this lesson. I hope now you know how to solve problems involving APs and GPs. Have a fantastic day. This is Mr. Lim signing out. Peace.